Welcome to a very sad day. This is the day the dinosaurs died. And yeah, it was pretty much a day that knocked them out. There are a lot of dinosaurs that were not doing well before this. But this is the death blow. This is the Mortal Kombat fatality move. Yeah. And it wasn't just the dinosaurs, it was a lot of stuff. So up here you can see a little animated GIF of the thing that happened. This is a large celestial body of some sort. Probably not a planet. People are saying large asteroid. People are saying large comet. And I don't know, a thing that has mass flowing from space, I think, is a good approximation. I don't believe we know exactly what it is that hit, except that it delivered a lot of radioactive space metal throughout the atmosphere, stuff that's commoner in asteroid belts, for example, than on Earth, and that this was the day the dinosaurs died. So when this thing hits, it hits so hard that it is vaporizing itself and a bunch of rock here. We don't have chunks of this thing because it vaporized and melted. And the melted parts then rain down over the entire globe. This thing hit so hard that it liquefied the rock and it created great big ripples in the rock. And this spot is in the Yucatan Peninsula. It's right down here in Mexico. This entire hypothesis and impact site was discovered by two guys. They're the Alvarez brothers. And I can't remember if they got a Nobel Prize for this, but dang, if it was up to me, I'd give it to them. Shown here, these are the cenotes in the region. And so the cenotes are... these are like underground little caves. There's a lot of limestone in that area. And when the limestone hollows out from like underground water running through it and dissolving the calcium carbonate, you end up with a nice little, it's like a swimming pool inside of a cave. And sometimes the roof will fall in so you can see what you're doing in there, and sometimes it won't. So this is where you get those neat cave fish, stuff like that. Really cool. If you're ever down in the Yucatan, it's worth it going to one and swimming in one of these caves. I have, and it was awesome. Yeah. But you can see a funny thing. So the caves are kind of distributed all over the place. Wherever there's limestone, there are caves. Wherever there's not limestone, there are not caves. And then you get a little ring of these things right here. And then you don't really get any on the inside. There are very few of these because all of the limestone that was there is essentially converted into metamorphic rock, or almost igneous rock, but it's metamorphic by the force of the blast. We are turning all of these nice sort of sedimentary rocks into impact breccias, which is the name for a type of rock that you get when you smash rocks together really hard, really fast, and they basically liquefy in the process. So, neat. I'll pause for a moment so you can read this. Yeah, I don't think no, you know what? Let's do a dramatic reading. Yeah. So we got the asteroid, whatever it was, asteroid comet thing, vaporized on impact. So its substance mingled with the earth rock form a fiery plume. So giant fire. Like imagine what's coming up from a nuclear blast, that mushroom cloud, but of vaporized and liquefied rock. This is then going to create a debris storm because all this liquid molten rock is going up in the atmosphere, and it's then going to cool and it's going to rain, but it's not going to rain water. It's going to rain boiling liquid rock, and that's going to rain down over all the land. And it may take hours, it may take a couple of days to get all the way to the other side of the planet, but this rain of red hot 500-degree rock coming from above and landing on firewood, forests, you better believe that starts these giant forest fires. At this point, we think most of the forests on Earth are on fire, and you get evidence of this all the way across the globe, even in the Indian subcontinent. You get evidence of massive forest fires, a giant ash layer as everything burned. 99.999% of all organisms living on Earth, in the oceans and on the land, died that day. The carbon cycle, plants capturing carbon, animals eating the plants, other animals eating the little animals. Yeah, that all ceases basically because of a thing that happened in a moment on a day. Let's learn about that. Let's learn about the evidence. So, here is evidence of the bad thing happening at Chicxulub. You've got a cross section of the deposit there. Here are some ripples in the rock, crazy. Here are, I believe, some of these pulses that are coming in over top of it. This is from North Dakota. And North Dakota is far away from the Yucatan. It's that little part that sticks out. It's like a knee coming off of Mexico. If Mexico's leaning back in a sun lounger, this is like the little knee that's sticking up. Yeah. And by examining that layer, what they're able to find in this little layer is an event of great big waves. So here's our little wave impact. Yeah, this is North Dakota, not Chicxulub. I'm a goofball. And then they're going to find gradual deposition of other things. Here they're going to find an ash layer. Oh, ash layer. Yikes. Inside the those wave layers, they're going to find these deposits with tons and tons of fish. The fish are all going to be dead, because that's how you become a fossil, but they're all going to be lined up. They're all going to have the same orientation, as if these were thrown out of the ocean by gigantic tidal waves. And yeah, when a thing like that hits, half in the water, half out, it's going to set off major earthquake type events. This is going to be seismically felt throughout the earth. And yeah, you better believe there are going to be associated tsunamis that are coming from this. And because there's so much energy involved, this is going to go on for a while. And the waves are going to be bigger than anything that anybody has ever seen before or since. So, yeah, here's showing a big pile of those carcasses. And so what they find are, here's going to be our mudstones. Here's going to be our evidence of gigantic ripples, which are from gigantic waves. And then we're going to get mudstone laid down, but it's going to be full of these little white dots. And these are spherules of ejecta. These are glass, and we'll show you in a minute. They've solidified on the outside, but the inside is still liquid. And glass liquefies or stays liquid at something like 500 degrees Celsius, I think. So these are extremely hot. These are little fireballs that just have a little crust of solidified glass that may have formed when they hit the ocean. But the inside is still red hot when they are raining back down. And they're raining down for a while. Yeah. You get sort of programs of these. You get the early ones that are landing not too long after impact, because these have got to transmit over thousands of miles. And if they can transmit from Central America to North America, they're also going around the world. They're going with the trade winds. All this energy is maybe changing the trade wind patterns. And eventually you're going to get a deposit of this iridium. The iridium is going to be enriched in some asteroids, and so that's why we think this may be an asteroid. But there's going to be a great big layer. But under this, you get the major storms, you get the molten glass, you get the ash. And this is going to mark the end of the Cretaceous and the beginning of the Paleogene, and it is going to be marked in fire and destruction. So, they call this site the Tanis site, because if you have an awesome site, why not give it an awesome name? That's fine. The formation is the Hell Creek bedrock. And there are going to be a lot of things. We think there was the ocean was here. And we're going to be throwing things up out of the ocean onto what was dry land here. And so this is going to be kind of at the fringe of the ocean. Stuff's going to be thrown up way onto shore. There are tons of trees that are knocked down and buried, tons of fish that are knocked down and buried, all lined up just perfectly by these massive waves, like what you see after a seismic event and a tsunami. So here is one of these little spherules, and these are the things that they find in layers all over the place. The sphereal, when they crack it open, you can tell the inside has not formed, it's not crystalline. So this thing was about halfway solidified, and half of it was still at 500 degrees. You better believe the outside was still pretty darn hot when it landed. And this may have landed weeks after the actual impact. So the entire atmosphere is on fire, essentially, during this event. And then it's raining down, burning little shards of glass. Here's little teardrop-shaped shards of glass that are raining down. Here are some of these things. Look, like little tiny, adorable marbles of glass. Here they are. We're sectioning through them right here. Here you can see some of them where they're falling, where things are falling from the sky, like little drop stones, fairly soon after the event. To fairly late after the event, but before all the dust settles. The dust settling is this iridium layer up here. Here you can see some of these little spherules, and the spherules show up. Look, here's one of the fish that was thrown onto the shore. These are the gills of the fish. The gills of the fish are loaded with these little spherules. These fish were trying to breathe, and they were breathing in molten glass spherules. And yeah, I think that would kill me too. Specifically, they are caught here because the fish was gasping, dying, maybe even being thrown up onto land. And all it could get, all that was coming in, were these little spherules. And yeah, it suffocated and it died and it burned. Yeah. Whew. So, bad day for almost everything that is on the surface of the land. A few groups that were living burrowed underground, and like way underground, and maybe with great big food reserves that they had stored underground. These things might be able to have survived in tree stumps, in little burrows that they made. But yeah, most of the dinosaurs did not. They were mostly on the surface, or these large dinosaur-like reptiles were swimming around in the oceans, and there was nowhere that they could hide. Especially if you're in the ocean, yeah, the entire ocean is going to heat up. It's going to be transient because you're just waiting until the energy from this impact is dissipated. But it's going to be a bad time for everybody for a while. And so that's the evidence from this particular site. And some of it's still a little bit controversial, but yeah, the Tanis site, they're calling it, up in the Hell Creek Formation up there in North Dakota. So, there you go. That's the day. And from the pollen, which is laid down just underneath all of this, they can estimate roughly when it's happening. I think this was in either the spring or the summer, I forget which, based on the types of trees that are flowering. And then after that, it's just ash and extinction and destruction. So there's not really much that could be done to prevent this. I mean, imagine with all our space technology, I don't know that we could do anything to substantially deflect an asteroid of that size if it was on a very fast collision course with Earth. Yeah, that's just how it goes sometimes. So this is the end Cretaceous extinction event. This is the day the dinosaurs died. Literally. All right. Thanks very much.